Earth's magnetosphere is an invisible shield, but without it, life on our planet would be in serious danger. This giant magnetic force field is created deep beneath Earth's surface by the movement of molten iron in the planet's outer core. That churning motion acts like a dynamo, generating a global magnetic field that reaches far into space and deflects harmful solar wind. The solar wind is a continuous blast of charged particles streaming from the sun at hundreds of kilometers per second. If Earth didn't have this magnetic protection, those particles would strip away our atmosphere and expose us to dangerous levels of radiation. Instead, the magnetosphere bends the solar wind around Earth and traps particles inside the Van Allen belts. Particles also get funneled toward the poles, lighting up the sky with glowing auroras. The magnetosphere forms a long tail that stretches beyond the Moon's orbit and reacts to solar storms that can shake the entire system. These storms can interfere with satellites, GPS, and even power grids. There's even a strange weak zone called the South Atlantic Anomaly, where radiation gets unusually close to Earth. And over time, Earth's magnetic poles wander, and sometimes flip entirely, switching north and south. By studying Earth's magnetosphere, scientists learn how planets defend themselves in space. It's not just a shield, it's a dynamic force field that constantly adapts, protects, and powers some of the most beautiful and extreme phenomena on Earth. True or false, Earth's magnetosphere is caused by the Sun's magnetic field wrapping around our planet. False, Earth's magnetosphere is generated by the motion of molten iron in its outer core, not from the Sun's magnetic influence. What creates Earth's magnetic field? Molten outer core motion. Fill in the blank. Earth's magnetic field is generated in the blank core. Outer core. Fill in the blank. The blank belts trap charged particles within Earth's magnetosphere. Van Allen belts. Where are the Van Allen radiation belts located? Inside the magnetosphere. If solar wind particles travel 1,200 kilometers across Earth's bow shock at a speed of 300 meters per second, how long does it take? To calculate how long it takes for solar wind particles to travel across Earth's bow shock, we'll use the formula. Time equals distance divided by speed. First, let's convert the distance into meters. The particles are traveling 1,200 kilometers, and since there are 1,000 meters in a kilometer, we multiply 1,200 by 1,000, giving us a total distance of 1,200,000 meters. Next, we divide this distance by the speed, which is 300 meters per second. So, 1,200,000 divided by 300 gives us 4,000 seconds of travel time. Now, to make that more understandable, we'll convert seconds into minutes. There are 60 seconds in 1 minute, so we divide 4,000 by 60, and we get 66.67 minutes. So, the solar wind particles take just over 66.5 minutes to travel across the bow shock at a speed of 300 meters per second. True or false? The Van Allen belts are part of Earth's magnetosphere and trap high-energy particles. True. Fill in the blank. The region of space controlled by Earth's magnetic field is called the blank. Magnetosphere. What natural phenomenon results from solar particles interacting with Earth's magnetic field? Auroras. Fill in the blank. When charged particles hit Earth's upper atmosphere, they create blank. Auroras. True or false? Earth's magnetic field protects us from most cosmic and solar radiation. True. A radiation belt particle moves at 500 meters per second for 10 minutes. How far does it travel? To find out how far the particle travels, we'll use the formula. Distance equals speed multiplied by time. The particle is moving at 500 meters per second, and it continues for 10 minutes. First, let's convert minutes into seconds. Since 1 minute has 60 seconds, 10 minutes equals 600 seconds. Now multiply the speed by the time. That's 500 meters per second times 600 seconds, which equals 300,000 meters. To make this easier to understand, we'll convert meters into kilometers. Since 1,000 meters make up a kilometer, divide 300. Which region has a notably weaker magnetic field, affecting satellites? South Atlantic anomaly. Fill in the blank. The blank monitors Earth's magnetic field from space in real time. Swarm. A probe travels 750,000 meters across Earth's magnetotail in 12.5 minutes. What's its average speed? To find the average speed of the probe, we'll use the formula. Speed equals distance divided by time. The distance it traveled is 750,000 meters, and the total time was 12.5 minutes. First, we need to convert the time into seconds. Since there are 60 seconds in 1 minute, we multiply 12.5 by 60, and get 750 seconds. Now divide the distance by the time. That's 750,000 meters divided by 750 seconds, which gives us an average speed of 1,000 meters per second. If we want to express that in kilometers per second, we just divide by 1,000, and we get 1 kilometer per second. So the probe was zooming through Earth's magnetotail at an average speed of 1,000 meters per second, fast enough to cover almost the entire length of the planet in just over a minute. How did you do? Tell us in the comments below. And thanks for watching Brainy Kids. We hope you had fun today. Like, subscribe, and hit the bell so you never miss a quiz. See you next time, brainy friends.